Hey everyone, welcome to this video. Let's talk about multi-head attention. So in the previous video, we talked about self-attention, where you compare the query with the key to find the similarity, use the similarity for the amount of value used in the output. And if you like to think of attention using my pizza analogy from before, you can think of the value as like the ingredient for the pizza. And this diagram you see to the left is showing an attention head. Let's talk about multi-head attention next. Kevin cooked a steak for his dog yesterday morning at the park for fun. What did Kevin do? Cook the steak for his dog? When did Kevin do it? Yesterday morning? Where? At the park? Why? For fun. So more than one attention is needed. So in multi-head attention, we could have 4 attention heads, where the first attention head says what Kevin did, cooked a steak for his dog, and the fourth attention head is focusing on why Kevin did what he did, which is for fun. Another way you can think about multi-head attention is of this picture of me. Now, obviously, the most obvious part of this picture is my face, so the first attention head will focus on that, and maybe the other attention heads will focus on less obvious things, like what I'm wearing, what's over my right shoulder, and what's over my left shoulder. Okay, and then for this diagram of an attention head to the left, let's simplify it down to just a square that says attention head, and the output is still context-aware word embeddings. So now in multi-head attention, in this diagram, let's go with an example of 3 attention heads. Pass the input word embeddings to the attention heads. Combine the context-aware word embeddings of all the attention heads, as we can see here. Use a fully connected layer / linear layer to get a desired shape, as we can see here. And lastly, output the final context-aware word embeddings contained results from all attention heads. And then if we want to simplify this diagram even further, we will simplify to just a square that says multi-head attention. What we have learned so far. 1. Context matters. At the county fair versus Judge Jamie's fair, where the word fair can mean like an event, like a county fair or a job fair, or where the word fair can mean unbiased. Basic self-attention. Measure similarity to get attention scores, to get attention weights, which will get you context-aware word embeddings, which ultimately gives you better output. The third thing we have learned so far is query, key, and value. And lastly, we learned about attention head and multi-head attention, which is more than one attention. As you have noticed, there's much more to understand for attention in transformers compared to the hidden state used in RNNs. For myself, it took me about a day or two to understand the basics of hidden state used in RNNs, but when it comes to attention, you have to learn all of this stuff here, and it takes a lot longer to learn and understand. So the most obvious question that comes to your mind might be, why should we care about learning all this extra stuff that takes longer to understand? It might be a bit harder to understand. And the answer for why you should care is because earlier on in the course, we talked about issues with using RNNs for sequence to sequence, right? Issue 1, no parallelization. Issue 2, only the encoder's final hidden state is used. Issue 3, RNNs at risk for vanishing gradients, so long sequences become an issue. Instead of using RNNs for sequence to sequence, what if we use something else called attention instead? Transformers use attention and are replacing RNNs for sequence to sequence. And in the next video, I will go into a deeper dive for a lot of the benefits that attention has over RNNs and hidden state. Okay, thanks for watching this video. See you all in the next one.